Good morning, everyone. My name is Luke, and today I'm going to talk about how we measure the impact of user reviews on Android app security and privacy. And this is a joint work with Eric, Michael, and Sven at the CISPA Helmholtz Center for Information Security. So let's talk about user reviews or app reviews. User reviews are useful because on one hand side, they provide other user insightful information so that they can decide whether or not to install the apps based on the other user's experience. On the other hand side, they also provide developers useful information such as user feature requests, user sentiments, as well as suggestions for improvements. And this is very important because this creates incentives for developers to improve their app toward better versions. So with that in mind, we ask ourselves three questions. First, do users talk about the security and privacy problems of Android apps in their reviews? Second, if they do, what makes them care about their security and privacy? And last, very important, do user reviews lead to app security and privacy updates? So to answer these three questions, we aim to study the connection between user reviews and Android apps security and privacy evolution. And now I'm going to give you an overview of our approach, and later on I will explain each component in details. So we start our approach with a crawler that crawls all app reviews and app version history. By saying version history, I mean we download all app releases. And for reviews, for app reviews, we want to know whether a given review is security and privacy related or not. Therefore, we built a review classifier using machine learning and natural language processing techniques. On the other hand side, we want to know whether a given update is security and privacy related or not. Therefore, we perform static analysis on the app version history. Once we have the set of SPR, which is the security and privacy related review, and the set of SPU, which is the security and privacy related app updates, we'll map them together using our SP mapping component. First, our crawler. So we want to crawl all our version history. Unfortunately, Google doesn't provide us such information, so we have to look for alternatives from third-party stores, such as AppAny, APK4Fun, and AppRent. And in this work, we focus on English reviews only, and we gather additional information such as rating score or the date that the review has been written. And we focus on the apps that have at least 50 million downloads, and this results in 2,583 applications, totaling in around 63,000 versions, meaning that an app has on average 24 versions. And all in all, this results in around 4.5 million reviews. So now we have the data set. The first thing we want to do is we want to know whether, or we want to have an automated approach to detect whether a given review is security and privacy related or not. But to do that, we need to define what is security and privacy related review. And to do so, we need to take a step back and define the term from the end user perspective, meaning that we consider what the end user can see from the Android applications. And therefore, we focus on permission-protected resources, because this is the only information that is visible to the end users, either by runtime permission mechanism or insert-time permission mechanism. And to enhance this definition, we also extract keywords based on existing literature on user perception of the security and privacy problems of Android applications. And when a review does not talk about any of these two aspects, then we consider them non-security and privacy relevant. To give you a few examples of how an SPR would look like, I'll give you some examples here. First, new permissions. Why would this app need access to my location? So here, the user is talking about his or her location permission. Secondly, the second user talks, why does it need access to my photos and videos? So in this example, or in this review, the user is talking about his or her storage permission. And last, why on God's good green earth does your app need access to my location info? 1 star for the privacy still. So in this example, the user does not only talk about his or her location, but additionally, he or she is expressing that about her concern regarding the privacy. So now we have the definition of what is a security and privacy related review, or what is an SPR. So we are going to build our review classifier. And to obtain a training data set, we randomly sample 4,000 reviews and manually label them. So we managed to label around 600 SPR and around 3,300 non-SPR. And some of the reviews cannot be labeled because they contain, for example, only one word, or they do not convey any information to the coders. To train our classifier, we use support vector machine and use bag of words to extract features for our classifier. And in particular, we use n-gram of characters to extract features. And before feeding the reviews to our classifier, we apply some processing techniques such as stop word removals or steaming. So to validate our approach, we use 10-fold validation technique on a set of manually labeled reviews, which is around 3,900 reviews, labeled reviews. And we use AOC metric to measure how well our classifier performs. And for those of you who are not familiar with AOC metric, this is an example of a random guessing classifier. You will have an AOC of 0.5, and which is denoted by the red line here. And if you have a perfect classifier, you would have an AOC value of 1.0, which is denoted by the blue line here. And our classifier has a mean AOC value of 0.93, which is denoted by the blue line here. So now we have a review classifier with an AOC of 0.93. The next step would be to detect whether a given update is security and privacy related or not. And again, in this step, we need to look at the definition of what is security and privacy related. So we only focus on what is visible to the end users, or what changes that can be visible to the end users, what the end users can see. And therefore, we again focus on the dangerous permission changes between app updates. But furthermore, we also want to know whether the runtime permission mechanism does, in one way or the other, change or have impact on the user perception regarding permission requests of Android applications. Therefore, we also want to identify whether an app version has runtime permission mechanism or instant time permission mechanism, and check with the number of SPR later on. So the goal here is to find out the security and privacy changes between any consecutive app versions. So now we have a review classifier and static app analysis. The final step in our approach is to map SPU, or the privacy and security related updates, to SPR, which is the security and privacy related review. And let's assume that we have an app, and this graph depicts the app timeline, and for the clarity, we only have 4 reviews. And let's assume that for the second review, our classifier has detected that this is indeed a security and privacy related review. If there is such review, we will look forward to detect or to ask, is there an SPU in the later versions of the apps? If there is, we would consider them as mapped. Of course, this is an approximation, and we will talk about that in a couple of slides. So now we have all components of our approach. Let's come to our empirical results. First, regarding the security and privacy related reviews, using our classifier, we have been able to identify 5,527 SPR, and around 50% of them we can categorize into different subcategories using keywords. And here, I list top 10 permission or permission groups that are mentioned in user reviews. And the list is headed by storage, contact, location, camera, and so on. So remember the point that I mentioned in the previous slide. We want to know whether runtime permission does, in one way or the other, have impact on the user perception of permission requests on Android. So we compare the amount of SPR, or the amount of security and privacy related reviews of app versions with runtime permission and app versions with instant time permissions, and we have found that app versions with runtime permission mechanism receive significantly more SPR in comparing to apps with instant time permission mechanism. And to give you a rough idea of how this trend, or how this looks like, this is an example of the amount of SPR of an app over time. And the x-axis represents the release of the apps, or the app version history. And here you see there's an increasing amount of SPR. And we look further into this, and we found that this is correlated with the introduction of runtime permission mechanism. So since the app introduced runtime permission, so it switched from instant time permission to runtime permission, and this is correlated with the increasing amount of SPR. So regarding the security and privacy related updates, using our static app analysis, we have been able to identify around 6,000 SPU. And here I list top 10 SPU, or the permissions that are removed in app updates. The list is headed by read phone state, get accounts, write, read storage, and location, and so on. So now there's a question. Is there any overlap between SPR and SVU, or do users talk about the things that developers are working on as well? Because even using our SP mapping component, we have been able to map around 3,500 or 3,400 SPR to SVU, which is around 60%. And to give you an overview of how the top SPR and top SVU look like, here we put two graphs together, and intuitively you look, there's a storage permission on the left-hand side, and there's storage permission on the right-hand side. So users talk about storage, developers removing storage. And similarly, we have a location. So this gives us a good feeling that it seems like they are talking or they are working on the same problems. So the real question now is, do reviews lead to app security and privacy updates? So to answer this question, we perform several regression analyses to find out the factors that have impact on security and privacy-related app updates. And we use logistic regression to do so because the outcome of our model is whether a given update is security and privacy-related. It's binary, therefore we use logistic regression. And we focus on two types of variables, user variables and app variables. But now I would jump directly to the results and I would invite you to read our paper to see how we build up the models and how we choose variables. So to summary, we have found that SPR indeed leads to SVU, meaning that the more SPR an app version receives, the more likely that the next update will be security and privacy related. Second, the higher a score an app version receives, the less likely that the next update will be security and privacy related. And third, the more developers reply to user reviews, the less likely that they will release SVU as the next update. And app versions with runtime permission mechanism are more likely to release SVU. And this is indeed in line with the previous finding that app versions with runtime permission receive significantly more SPR in comparing to app versions with insert time permission. So to conclude, in this work, we have found that users do express their concern about the privacy and security in their reviews. And runtime permission mechanism does raise more suspicion from the end users. And last but very important, SPR or security and privacy related reviews do have impact on app security and privacy update. Impact, or here I mean positive impact. So with this work, we call for action to make our behavior more transparent to the end users, which would have to leverage their feedback that creates incentives for developers to adhere to security and privacy best practices. At the same time, our work also called for action to make tool support for developers who better adhere to security and privacy best practices. And with that, I would like to thank you very much for your attention, and I'm happy to take questions.
So we have time for questions if folks want to line up at the microphones, and please give your name and affiliation if you mind.
Good morning. Thank you very much. Very nice talk.
Thank you.
Did you actually see developers that retracted some feature actually cancel it because of a review?
Can you repeat, please?
For example, if somebody has an app with location services that don't need to be in the app, and there are complaints about that or concerns about that, have you actually seen indication that somebody pulled it out of the software?
Good question. So we actually, to verify the ground truth of such situations, we look into the replies of developers to such SPR, to such complaints, and we have found that there are several situations. First, there are cases developers, for the majority of cases, developers would remove such permissions, or they will explain why their app needs such permission. And sometimes they don't remove, but they explain. And the other time they explained that they have to change from install time permission to runtime permission so that they can request the permission only when the functionality of the app is needed. Thank you.
Hi, I'm Damien from Google and ETH Zurich. When an app has less SPUs, do you have a sense of when it means that the app is already doing the good thing from a privacy and security perspective, in which case there's no more updates because it's already doing sort of the best it can, or whether it's actually improving? Because there's a lot of signals like the fact that developers who answer or use runtime permissions gets less NPUs. It could mean that just the app is already doing good, right?
Yeah. So we also look into the attribution of the permission usage of the apps, and for the cases where developers don't update or they cannot remove the permissions, they explain that for the majority of cases, the permissions are used by third-party libraries. So they cannot do anything about it. Thank you.
So I had one last question, maybe.
Yeah.
Right now, everybody is using reviews as the mechanism to give feedback to developers. Is there a value to that being public, or do you think a separate forum for surfacing this to developers actually makes sense?
Do you mean surfacing this approach to the?
Right now, users have to write into reviews, which have lots of things that are going on, and developers may not see it.
Yeah.
But if you had a separate feedback mechanism, specifically, say, for security or privacy or permissions, you can have value there, but maybe that hides it from users. I didn't know if you had an idea of what's the approach to surface this easier to developers.
So I think if you just have a separate channel to notify developers, then you are removing the incentives part of the other users. For example, if you complain a lot about an app and you see that an app has low rating, then you wouldn't download or install the app. So I think it has to be public. The channel here, the review channel has to be public. Otherwise, it loses the incentives for developers to improve their app toward better versions. Thank you.
All right, let's thank the speaker again.